Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. So today we are going to continue with our AP Calculus BC exam. In the first session, we did the first 10 problems, and there were like few typos. I tried to check those before we start, but I think the next 10, which I intend to cover today, don't have any errors, but if we find something along the way, I'll try to correct it. I'm sorry for that. Maybe I'll try to find different exams, maybe from from a different site or something. Anyway, so we stopped after 10 problems. Problem number 11, they give you a table in which they give you the x and f double prime of x. Okay, so the second derivative. And you know the second derivative, it gives us whether I have a concavity up or down, or no concavity if it's an inflection point, so on and so forth. So they say the polynomial function f has selected values of its second derivative f double prime given in the table above. Which of the following could be false? Not necessarily false, but could be. Okay. Part A, they said the graph of f changes concavity in the interval -2 to +1. -2 to +1. The concavity was positive, then it became 0, then it became negative, so it changed. Instead of being concave up, now it's concave down. So that is correct, right? We cannot say it could be false. There is a point of inflection on the graph at f at x equals 0. Yes, at x equals 0, f double prime is 0. That's an inflection point. Okay, how about C? The graph of f has a point of inflection at x equals 1.5. We don't have a value of 1.5. It may or may not be. We don't know that exactly at 1.5. We have a 0, so definitely C is the wrong, or could be false. Just to check the rest, but you don't need to. It says the graph of f is concave down at x equals 1. At x equals 1, the concavity is negative, so it's opening down. That's correct. The graph of f changes concavity in the interval 1 to 2. Yes, it was negative, it became positive, so definitely it's C. So number 11, the answer is C. Okay. So that was easy. Let's look at number 12. Okay, number 12. They give you y equals the cube root of x plus 2 square times x minus 4 cubed over x cubed minus 1. And they want the derivative of y with respect to x. Well, if you get a problem like that, don't ever try to take the derivative while you would use a quotient rule and chain rule. That would be messy, right? So how do we do that? Since you have a root and a product and a quotient, the best way always, whenever you see a problem like that, your best bet is to use the logarithm. So I can say log of y, or natural, it doesn't matter log or natural log, but natural log of y equals the natural log of the first hand side. Notice that the cube root, meaning this power is 2/3 and this one is just 1, because the cube root of x minus 4 cube is just x minus 4, and it's x cubed minus 1 to the 1/3. We learned from logarithms that if I have a product, it becomes addition, and if I have division, it becomes subtraction. Meaning, I can say this is the natural log of x plus 2 to the 2/3, or I can bring the product as a multiplier. So to just save a step, or do you want me? Let's do it. let's do it the way, one step at a time. Okay, so this is to the power of 2/3. Plus, because that's a product of two things, so it becomes an addition of the natural log. So plus natural log of x minus 4, just, it's 3/3, right? So it's 1, minus natural log of x cubed minus 1 to the 1/3. As I said, we can simplify that by bringing the power as a product, so that becomes 2/3 natural log of x plus 2 plus natural log of x minus 4 minus 1/3 natural log of x cubed minus 1. I'm taking more time than you should in the test, right? Then I will take the derivative of both sides. We know that the derivative of natural log of y with respect to x would be 1 over y times dy dx. Okay? Equals 2/3 is a constant. The derivative of natural log of 1 of x plus 2 is 1 over x plus 2. Plus the derivative of natural log of x minus 4 is 1 over x minus 4. Minus the derivative, first of all, that's the derivative of natural log of x cubed minus 1 is 1 over x cubed minus 1. Don't stop here because you have to apply the chain rule. That's the derivative of the natural log function. But when you step inside, you get x cubed. So you're going to multiply that by 3x squared. The 3 and the 3 cancels out. Then I'm going to multiply both sides by y. Notice that you can see the answer right there. I'm just showing you the full answer. Dy dx becomes y times. So once you look here, of course, all of them have y multiplied. So you need 2 over 3 times x plus 2 plus 1 over minus x squared over, so it's a, right? 2 over 3 times x plus 2 plus 1 over x minus 4 minus x squared over x cubed minus 1, and that's basically it. It shouldn't take you that long. I'm just showing you, step by step, but you could see right away. Right when you are here, you can find the answer right away, right? You can exclude some of them. You have, for example, you start with 2/3. This doesn't have a 2/3. This doesn't have a 2/3. So you exclude B and E. And then you look at the second one. That's plus, that's minus. So you can see, you can exclude B and D, and you can find it's A right away. Okay? So that's the second one, number 12. Let's move to number 13. It's a new page. Number 13 and 14 are on a single page. Number 13, oh, that's a child play. Y equals x cubed plus 3x squared plus 5, and you want dy dx. Well, you can just look and say it's 3x squared plus 6x, which is b. So that doesn't take 5 seconds, right? So here you say dy dx equals 3x squared plus 6x, and that's b. Is it b? Yes. All righty. Let's move to number 14. Number 14, they give you f of x. Right? All of them, they are asking for derivatives. Okay, x cubed plus 2x minus 1 over x squared plus x, and they want f prime of x. Well, here you have a quotient rule, right? You can see also, you can I think you can do some elimination to get go, but it really doesn't matter. We know that to find the derivative of a quotient, we square the quotient, we square the denominator, and then you multiply the denominator by the derivative of the numerator, which is 3x squared plus 2, and then you subtract the numerator times the derivative of the denominator, which is the 2x plus 1. Okay. Do we have, so we have x squared plus x minus, it's also a. No, I'm sorry. This is x squared plus x. Why did I write minus? Yeah, it is a. What's the difference between, oh, I'm sorry, it's b. It's square. Okay, so you have to be very careful because they are very closely related. So first of all, we can exclude a because it doesn't have a square in the denominator, but then b should be the right one, right? Yeah. What's wrong with c? Oh, there's 3x squared. No, it's then it's c. You see, I would get this one wrong. It's so confusing. Yeah, it should be c. So what's wrong with d? There is a 2 here. And this one has a plus. So it has to be c. Oh my God. So first I thought it was a, and then I noticed there is no square. So I said, okay, so it must be b. And then I realized that I have 3x, not 3x squared. And finally, we said it's c. So it would take me longer than it should. That's crazy. Okay, so we did 13 and 14. How about 15? Okay, 15 says also they want a derivative. That's too many derivatives. I don't know. F of x equals 2 sine of cos of x. So chain rule right away. Chain rule is very easy. I think I went over a session to explain how you do it. 2 is a constant. You see, you have a sine and a cosine. And if this wasn't x, if it was like 3x or x squared or square root of x, then you will have 3 things. But here we only have 2 things. First of all, you take the derivative of the sine, which is cosine, and the rest stay as if they were constant. Then you step inside, you see cosine of x, which is negative sine of x. In fact, then you go inside of x, and the derivative of x is 1, so you multiply by 1. So eventually, this is negative 2 sine of x cosine of x, whatever that means. Oops. Yeah, that should be a. Negative 2 sine x cosine of x. Yeah, there is a negative sign, so E is not right, C is not right. This one is cosine, but you took the derivative of cosine, so you get negative sign. Okay, so that we said this is B, right? Yep. No, we didn't. It's A. Oh my God, it's so confusing. Negative, it's A. I said A in the beginning, and then I don't know why I changed my mind. Yes, it is A. Okay. Yeah, that's why you have to be careful and at the same time work fast. So it's a challenge. In fact, when you talk, explain while you are solving, I get sometimes distracted. If you were just solving, it should be easier, but anyway. Alrighty. Implicit differentiation number 16, it says find dy dx if x cubed plus 3x squared y plus 3xy squared plus y cubed equals 27. I don't care about the 27. It's irrelevant, right? Because we are going to take the derivative. Implicit differentiation with respect to x. I need dy dx. So I say, okay, the derivative of x cubed is 3x squared. Plus, then I have a product. I have x squared times y. So I can take the first times the derivative of the second, which I'm going to call y prime instead of writing dy dx every time. Plus, the 3 is a constant. The second times the derivative of the first, which is 2xy. Same thing here. I have 3x times 2y y prime plus 3y squared. And the derivative of x is 1. Plus 3y squared y prime equals 0. So now I'm going to combine the terms that have y prime. I have 3x squared plus 6xy plus 3y squared y prime equals. And then I'm going to move these terms to the right-hand side as negative. 3x squared plus 6xy plus 3y squared. And you can see that this is exactly the same thing. So if I divide right and left by that, I get y prime equals negative 1. That was easy. And this, there is no way you get it wrong. It's E, right? That's simple, so I won't get it wrong. Oops. Okay, let's move to number 17. Number 17, oh, okay. Related rates. Water is filling a conical cup. So I have a conical cup and water is filling at a rate of 2/3 pi cubic inch per second. If the cup has a height of 18 inches, and a radius of 6 inches, how fast is the water level rising when the water is 6 inch deep? So if the water here is 6 inches, we want to find dy. Okay. The first thing you see is that the radius over the height, the radius equals h over 3. Right? And it stays that at any level. Oh my God. Every time I start this session, I lose a pen. Okay. Let's make it clear. H over 3. So now I have two things. I can say, I know that the volume of a cone is 1/3 the area of the base, right? Which is at any level, it's pi r squared times the height. But then the height here can be written as, okay, times the height. We know r, I want to write r in terms of h so that because I want to find the derivative. So let's say, call that dh. And the 6 here is h, okay? So I want everything in terms of h. So that would be 1/3 pi times h over 3 squared times h, which is 1/27 pi h cubed, right? Now, if I take the derivative with respect to time, because we want to see at what rate the height is going up, so dh by dt, I would say dv dt equals, I take the derivative with respect to time, both sides. Pi over 27 is a constant. And the derivative of 3h squared would be, I'm sorry, of h cubed is 3h squared dh dt. But they give me dv dt is 2/3 pi. So I equate that to 2/3 of pi. Okay, so you see how we relate that both to each to themselves. So first of all, I can simplify pi with pi. 3 with 27 is 9, and 3 with 9 is 3. Now, h, they give me h as 6. So h squared is 36. 36 divided by 3 is 12. dh dt equals 2. So dividing both sides by 12, I get dt by dh by dt is 1/6 inch per second. 1/6 inch per second is part A. Okay, so be careful here. You have to know the volume of the cone. Okay? And then you have two variables, R and H, and you want the how high or how fast does the height change. So you want everything in terms of h. So you would say, oh, r is h over 3, and you write it in terms of h. H over 3 squared is h squared over 9 times 3 is 27. That's why you get that. Now you take the derivative with both sides. You get dv dt, which is given to you. They tell you that the water is added at a rate of 2/3 pi inch cube per second, dv dt. So dv dt is 2/3 pi. Okay, and then you take the derivative with respect to h. They give you h as 6 when it's 6. When it's 8, when it's 9 would be different. I would substitute with whatever, but this relationship will not change. What changes would be the h. I can find how fast the height go, which would be smaller as we go up, of course, right? Because the area gets bigger. And the quantity of water is constant. So we understand that, but that's why they have to give you the height at which they want you to calculate. Okay, so that's number 17. Let's go to number 18. So far, we didn't have any errors, thank God. Okay, number 18. Find the derivative again. Okay, we want the derivative of log to the base 8 of x squared plus 2 cubed. Yeah, some people have trouble with the derivative and integration. Should I multiply by log or divide by log? It's easy. You have to remember the law that tells you log to the base b, any base of a quantity, let's call it a, equals, you can write it as a log to the base 10 common, or Napierian or natural to the base natural log. So this, since we are going to take the derivative, then natural log makes more sense. This is natural log of a over natural log of b. So I can rewrite this as natural log. In fact, the 3 again, because like we did before, we can save time by write it as 3 natural log of x squared plus 2 over natural log of 8. I don't know if they want this natural log of 2 cubed, and the 3 would come down and cancel, and you get natural log of 2. No, all of them have natural log of 8. So when I say if this is f of x, so f prime of x. First of all, the 3 over natural log of 8 is a constant. And then you take the derivative 1 over the natural log x squared plus 2 times the derivative of that, which is 2x. So I get 6x over x squared plus 2 times natural log, which one? Yeah, b, right? 6x over x squared plus 2 times natural b. Okay, no need to memorize. You just know, you should know this law, right? You say, okay, I'm going to memorize it. Okay. So that's number 18. That leaves us with the last two problems for today, and then we'll finish that section hopefully in the next session. Number 19. What curve is, oh, that seems to be ridiculously easy, right? Cos squared t and y is sine squared t. So parametric equation, but we know that sine square of t plus cosine square of t equals 1. So I can say x, which is sine, or this is y plus x equals 1. And that's the answer. So easy, right? Yeah, we have all of them in terms of y. So I'm going to subtract x from both sides. And I say negative x plus 1, which is b. At least this part of the test is so easy. It didn't take any time. Number 20. Number 20 says, given the position vector x of t equals t cubed minus 18t squared minus 84t plus 11 for t greater than or equal to 0. For what values of t is the speed increasing? And here you have to be careful. I know that the derivative of the position vector with respect to time would give me the velocity. Oh, let's leave that because it has the answers. Okay, so v of t, which in physics usually we call it x dot of t, meaning the derivative with respect to time, is 3t squared minus 36t minus 84. Okay? And if I want to see when is the speed increasing, I will have to take the derivative of the velocity with respect to time to get the acceleration, and then equate it to 0. And well, we'll see. We'll see if it's increasing or decreasing. First of all, notice that this function, excuse me, I'm going to, if I want to plot it, 3t squared, notice all of them are divisible by 3. So I can say this is like t squared minus 12t minus 28. I'm going to equate that to 0 and solve. I get negative 14 and positive 2. So t minus 14 times t plus 2 equals 0. This will give me t negative 2, but t is greater than 0, so t equals 14. Okay? Notice that this also is a parabola. If you want to plot it, it has the minimum at negative 12 over 2, which is negative, over negative 2 is positive 6. Oops. Let's say the x-axis is here because the y-intercept is negative 28. It goes at negative 2 and positive 14. Right? And x equals 6. Well, it really doesn't matter. You don't need to plot it. You just need to see how it looks. Here you have to be careful because we want to find the region where the velocity is increasing. And that's why many people would say, oh, the velocity is increasing after 6, right? And they would pick t is greater than 6, which is d. That is not correct. Why isn't it correct? Because maybe the velocity, you see here, the speed increasing, if the speed and the acceleration are in the same direction, right? Maybe the velocity is decreasing. If I'm going at a particular speed and the acceleration is in the opposite direction, so we have to find the acceleration of t, which is or x double dot of t, which in this case you can use it here. 2t minus 12, you equate it to 0, and you see that what do we have here? So t equals 6. Okay, so now let's look at from 0 to 6. Let's say from 0 to 6. From 0 to 6, the speed is negative, and the acceleration is also negative, right? So you are moving in the opposite direction, but you are speeding because the acceleration is helping you. Do you see from 0 to 6, the speed or the velocity is going down, and from 0 to 6, the acceleration is also negative. So from 0 to 6, how about from 6 to 14? From 6 to 14, the speed is going from 6 to 14. The speed is still negative, right? It's below the x-axis. It's still negative, but the acceleration is positive, because if you substitute any number between 6 and 14, let's say 10, you get 20 minus 12 is 8. So they are opposite directions, so the speed is decreasing, not increasing. And finally, if t is greater than 14, we know that the speed is positive. Notice here it's negative. It's getting it's negative, but the acceleration is positive. The acceleration would remain positive after that, because once t exceeds 6, it's always going to be positive. And we know that the speed after 14 would be positive, right? So both of them are positive, and that would be the answer. T is between 0 and 6 union t greater than 14, which is B. So this answer is B. And it's a little confusing here, because many students would they would say, oh, the speed is getting down and then it increases. Well, that is not what the problem is asking. Okay? Because we know that the magnitude of the speed is getting down. So even though you are moving at a speed of we can calculate it at 6. The speed 3 times 36 is 108, minus 36 times 3 is 108, minus 84. So this is negative 84. Yes, it's increasing, right? It's not increasing, it's getting slower because it was moving in the opposite direction at a speed of 84, and then it will go down to 28, then to 0. Notice it's a speed, not velocity. The velocity, the speed here is decreasing, not increasing, because you were going in one direction at a speed of 84, and then you will start slowing down until you stop, and then you are going to reverse and move in the positive direction. That's why it's a little confusing. Here, the speed is increasing from 0 to 6. You were at speed of 28, and we went up to speed of 84. So even without taking the acceleration, you can see that in terms of speed, we don't look at direction. The speed is a scalar quantity, not a vector quantity. Okay, so you were speeding at 28 and you went up to 84, but then you will decrease to 0 and then increase again in the opposite direction. Okay, so that is a little tricky. You have to be careful when you solve it. I know time is of essence and you may be rushed and pick the, t is greater than 6, but in every exam there would be some problems that are a little tricky. But I wish you all the best. If you have any questions, please let me know. I will try to respond to you as soon as I can. Otherwise, have a nice day and hope to see you soon.